So, so before we dive into the program fully, okay, I would like to take us, you know, on some data analytics concepts, very few ones, just summarize so that we can understand when we are trying to do some analysis, because it's not just about having the data and just going into it and plotting graphs and all. We have to make some form of hypothesis. The program we are working on is the client wants to understand the behavior of our customers in terms of buying of ships. Okay, so it's a very big mall, and the manager of the chips category, they have different kind of products, maybe the butter, the cheese. So it is the manager of the chips category that came to us as a client to help us understand the behavior of the customers towards buying of chips. Okay, that is potato chips, or whatever chips, as far as the chip is there. So that means the amount of data that was given, we would have to filter it to that of only chips. Okay, the, the data that was given to us um, consists of all the products combined, all the product, the chips, the biscuit, everything. But since what we are facing is for chips, so we have to filter the data to chips. But then there are still some additional information we need to get from the data, like the amount of customers that bought chips. So once we have filtered the data sets for both the behavior and the customers transaction sheet, we have to count. So we need the total number of the customers that bought chips. We need the total number of customers that the shop has, so we can compare those things. Sha. So we'll not go into those deep things today, Sha, but like I said, the data set is plenty. Damn, man, even Minitab may not be helpful, because I tried doing something on Minitab and, well, not necessarily sharp, but let's get there. Minitab, you don't have to copy out all the data. Minitab and Excel works hand in hand in that you don't have to save all the data on Minitab. You just go to Excel and copy what you have, or what you need from Excel, and then go and paste it on Minitab and do your analysis basically. So at some point we might have to learn a little bit of Python, so that we can, because it will be easier for us to do this thing. So I'm just concerned about those of us that are not programming inclined, but it's simple. Python is a very friendly programming language, something that you can easily read, unlike the rest of the ones that looks quite complex. So let's start the program to just know some basic data analytics concept, okay? So data analytics, right? That's what we are doing, but we need to understand the meaning of of data analytics and the terms related to it. So the term data analytics refer to the process of examining data sets to draw conclusions about the information they contain. So basically, what we do in data analytics is we hold on. This person that joined, I'm very sure he has not used Zoom before. So let me just try with chatting. Join the audio by clicking on the headset icon. Okay. Shagun Afa, you're welcome. So I was trying to explain what data analytics is all about. Okay, before we go into the program proper, let's understand what we are actually doing on the, or going to apply in the program. So the definition of data analytics is simply the process of examining data sets to draw conclusions about the information they contain. So what we do is we work with data, okay? if our clients want to know something about their business, they want to know which customers buys a particular product, most often. They want to know which customer comes into their shop most often. They want to know what days they sell, at the higher. So this kind of business questions, and not only for business, you can also use it for agriculture, for science, for engineering. You can apply data analytics anywhere, but it boils down to using data. So what we need for our operation in data analytics is data. Okay, so we use data to draw conclusions from. We use data analytics to draw conclusions from data. Okay, because data is just like, it's not like in computer we have data and information. Data is um the raw file that's yet to be processed. Okay, so if we are given data, we can't basically know anything. We're just seeing series of numbers, series of text and all. We can't get a sense of it by looking at it. But with the use of statistical tools and softwares like Minitab, Excel, Python, and the likes, they help us to understand the data more, to explore, and to do whatever analysis we can do to answer our questions, because that's what we want to do. We want to answer some questions so that we can drive business, we can increase profit. So data analytics techniques enables us to draw raw data and uncover patterns to extract valuable insights from it. So that's what we are doing basically. We want to extract valuable insights from data. So data can be used in a project to analyze several aspects. Okay, we can use it to find the biggest problems in our. We can use data to find the biggest problem in our project, our industry, our business. We want to know what kind of operation takes our time the most, what kind of operation costs the most, and why are these happening. You get, so these are what data helps us to answer, so that we can effectively run our business at low cost. Because of course, what do you want to do? We want to run business at low cost and make more profit. So we can also use data to diagnose the current process. We want to know what's going on. Let's see if we are doing well or we are not doing well. Let's compare our last year's transaction or our last year's sales to this year's sales. So we need data, and we need data to investigate the effect of improvement. Investigate the effect of improvement means maybe in your company you decided to bring up a new concept. If you make, okay, this is a um, what kind of, okay, let's say you are in a sale, you are in the sales business. Okay, you're selling stuff, and then you now decide to experiment something. You now give some of your employees, like some of those your sales rep, you give them a particular training on effectively selling products. So you give them a particular training, and you don't give some guys that same training. So after the training, you now let them keep working. I'm recording the meeting already. Shagun, I'm recording already, so I'll send the video to us. Okay. So you now want to investigate the effect of the training that some of your employees did. So you let them work after the training. You let those that had training work. You let those that did not have the work the same way they've been working. Maybe after months or a year or so, you will now say, okay, let me now get the records of the sales from those that got the training and those that did not get. So what do you want to check? You want to check the effectiveness of the training. You want to know if the training that okay, let me see. Okay, don't worry, I will send the video. Don't worry, just just sit tight and focus. Okay. um so we can use data. So how do we investigate if the training has an effect on our sales in terms of since different set of employees got the training? You are going to get data from both guys from their sales record. So when you got the data, we'll now analyze it and check. Oh, those that got the training, did they increase, like did the sales increase? you know um in comparison to the guys that did not have the training. So you can use data to investigate if that training actually made an effect on the business. Okay, so these are what you can use data to do. So that's the power of data. You use data to do a lot of things, but you need to truly understand how to use it. Okay, you can't just get data and say, oh, let me no, you have to understand what you are looking at. Okay, so let me just give you, so there are types of data. Okay, we have different types. It's something basic. We have the numerical type of the data, which is the quantitative data. So these are data that are real valued or whole numbers. You get 50, 25. They are basically data that you can do arithmetic operations on. You can add them, you can subtract them, you can divide them, you can multiply them. You get. So we have also two types of this kind of data. We have the discrete type. Discrete type is just like 1, 2, 3, 4 without the decimals. Okay, that is discrete. 10, 20, 30, 40. You get, just like how will I put it? Maybe your time, digital your digital clock. Okay, it does not have um decimals. It just gives you your digits, not decimals. Then we have the continuous. Okay, example of discrete, uh the number of people. Of course, we cannot have half people now. If we say count the number of students in this class, it will be okay. We have 30 students, we have 20, we have 50. We cannot say we have 50.5 students. Who's the half person? Is there half human being? No. We have number of mistakes. You cannot have half of mistake. So these are discrete variables. Then another kind of numerical data is continuous data that are not limited to integers, such as distance. Okay, you can move 5.5 meters from where you are. So that is something continuous. Also, temperature. Instance, we can have 35.5 degrees Celsius. You get. So these are numerical data that can be continuous. So that's the difference between discrete and continuous. Okay, and in real time, we are we are faced with continuous variables. Okay, the temperature, the humidity, different things. Even our what's it called? Okay, for instance, let me give us an example. If you have a speaker, right? You have a speaker and you want to reduce the volume. What do? You cannot just go from low to high direct. You get, like, except you want to just spoil it stereo. You can't go from low to high. You have to go from zero. Let's say even from 0 to 1. In the digital world, we are left with 0 and 1. Okay, so let's say 0 is for low and 1 is for high. So, and you're dealing with a speaker. Before you can get from 0 to 1, you must pass through 0.1, 2, 3, 4, 5, 6, so that it will be increasing like that. And when you get to 1, it becomes the highest value. So that's the difference between discrete and continuous. Okay. So it's important we have to understand the kind of data we are working with. And the second type of data we have is the categorical data or the qualitative data. Okay. So this data that subtraction and addition have no meaning. It will not make sense to add this kind of data or to subtract them or to multiply them. Like, that's not, it won't make sense at all. We can't say maybe Michael and say 2 times Michael. You can't say 2 times Michael. You can't say 2 times stable. You get, like, these are kinds of categorical data. So they're basically like um alphabetic. Okay, we have three types of this kind of data. One is ordinal. Ordinal data is got from the word order. Okay, so this kind of categorical data, they are well defined. Example is there. We have good, we have acceptable. For instance, now we have good, bad, worse. Good, bad, worse. So if you want to put it in order, I would say from good, then bad, then worst. Abi now, or good, worse, worst. Good, worse, worst. You know what I mean? You can order, okay, like first, second, third. First, second, third, fifth. This is an example of ordinal data because we can put them in order. Okay, we have another type of categorical data called the nominal data. Nominal is from the word nomen, which means name. So it's like, name, basically the name of a country, name of a person. So they are unordered. Okay, they are merely labels. Name of a product, For instance, look at the example I gave: XOMMSWLS, or North America, Michael. These are name form of categorical data. And then we have the last kind of categorical data, which is binary. So binary data are those data that has two arguments, two inputs. For instance, true or false, pass or fail, male or female. You get those kind of things that are just two kind of words that you can use on them. Do you understand? So these are the types of data that we're going to be encountering in the program that we are working with. So it's important to know the different types so you can know the kind of technique to use in terms of data analysis, to know the kind of charts to plot on them. So visualizing data. So visualization is very key. In fact, it's one of the most important things in data analysis. We can, instead of all those looking at the data, we can just plot graphs. Visualizing data just means plotting of graphs, basically. When I say data visualization, it doesn't. The thing just means data charts or plotting of charts, plotting of different kind of charts, and we have different type of charts. We have different types. If you are the one that is used to Power BI or Tableau, or even there are websites that you can see numerous kind of visualization, but you have to understand what you are looking at. So I'll be giving us a guide, okay, for the few kind of charts that we can use and the kind of data. Okay, now look at the 3D diagram. Okay, for if we are to plot a graph actually, okay, we would have we have two axes, y and x, right? We're having y and x. So our y will be on the vertical axis, and the x will be the on the horizontal axis. So the y variable, okay, let me give us an example. Y equal to 2x. Y equal to 2x. So if the value of x changes, the value of y will change, in corresponding. That means x is an influence on y. So our y variable is the variable we are interested in. Is the variable, for instance, that example of the training I gave, the training, if you want to know if the training you add on your employees has an effect. So let's say we are interested to know the number of sales, okay, the number of sales per employee. So our y variable, there will be number of sales. Why the x variable will be the training, because the training is the influence factor on number of sales. So if I have to plot the data, our y variable will contain the data of the number of sales, is what we're interested in, and our x variable will be the training, which is the influence factor. So another thing to note in data analysis is you have to know your influence factor and your y variable. Your y variable is what you are interested in, your project. Okay, you want to know let's say maybe a lot of things, but it's not what you are concerned about. Then okay, for instance, you might be concerned about maybe you're working on a project in terms of science, and you want to know the effects of nicotine, or you want to know the effect of depression or nicotine dependence. Nicotine is a substance that can be found in cigarettes or tobacco, right? So you're not studying that why do people smoke. Then you're now saying, okay, could it be depression? Could depression be a cause of nicotine dependence? So what are you interested in? You're interested in nicotine dependence, basically. That's what you are studying. So that'll be your y variable. So what is the factor that you think will influence nicotine dependence? That's depression. So the depression will be your x variable, because you are trying to see depression as an influence factor on nicotine dependence. So basically your y variable is not what you're interested in, and your x variable is the influence factor of what you're interested in. So look at the chart I gave us now. We need to know the kind of data our y variable is and the kind of data our x variable is, to enable us to effectively visualize it, because you can't just plot any graph or any data. So this is a guide. If your y variable is numerical and your x variable is numerical, you can plot a scatter plot. Scatter plot is just the normal kind of plot to plot in our basic maths that will say plot this against this. Basically, most of the things we plot then in secondary school are numerical data. Plot temperature against humidity. Plot maybe you're dealing with physics. Plot focal length against this and that. So these are numerical data. So the kind of chart that we plot for numerical data for X and Y variable is scatter plot. We'll see all this as we go. The kind of chart you should plot for a numerical Y variable and a categorical X variable. See that it's changing now. If your X is categorical and your Y is numerical, you should make a box plot or individual value plot. Okay. We will not really go into all these guys in the program, but I just wanted to have a feel of what data analytics really mean and understand what you are going into. So we'll just apply whatever we need to the program, okay? But let us know all these things. So if your Y variable is categorical, okay, and your X variable is numerical, you plot a box plot with groups. So like the previous one, when your Y is numerical and your X is categorical, you plot a box plot. That box plot will be vertical, basically. But for the Y variable being categorical and your X variable being numerical, where we are now, you're going to plot a transposed box plot. You can plot these guys on Excel. You can plot these guys on Power BI, on Tableau, on Python, on anywhere. Okay, you can plot these guys. So it does not actually matter the kind of tool you are using. What matters is you knowing what kind of chart to plot. Do you understand? That's why I tell people that when you are doing data analysis, understand data analysis before actually even knowing the kind of tool you want to use. Because the tool is a secondary choice. What you need to know primarily is how to analyze data. So this is a guide. So if your Y is categorical and your X is also categorical, you can plot a stacked bar chart. A stacked bar chart. You know, we all know what a bar chart looks like, okay? So a stacked just means you're putting another bar chart on it, okay? So let's just go. So this is statistics, okay? Let me explain some concepts in statistics. So first we have the population, okay? Now population is the entire group you desire information about. Okay, for instance, my example of nicotine dependence and depression now. Imagine you want to study this over Nigeria, like maybe on Nigerians. You are studying Nigeria as a population and you want to know if depression causes nicotine dependence, or in a simpler term, if depression causes smoking, okay, or addicted to, or being addicted to smoking. So your population basically is the whole Nigeria, and we are about, let's say, 300 plus million, okay, in Nigeria. But it's not actually possible to cover all of them, okay? But that is the population. But it's not possible to have data on all of them at once, or even to analyze all of them. It could be possible, but it might take us maybe 50 years to, or so, or if you have a better way of gathering data. But it's not actually advisable because mostly it's waste of time per se. So what we do is we get a sample from the population. So the sample is a subset of the population taken because the entire population is usually too large to analyze, like I've explained. To analyze the whole Nigeria. In fact, there are some studies that you might even want to analyze the whole world. I see that it's even quite impossible to analyze. But what you can do is to take the sample from the population. So it's a subset of the population. But then when you are taking your sample, you have to be very careful because you can't just take any other sample. Your sample has to be representative of the population. That means whatever sample you are taking should be able to, cover every aspect of your population. In Nigeria, we have how many tribes? Maybe maybe the famous tribe below is three: Hausa, Yoruba, and what? Igbo. So your sample should cover those three tribes. You should cover everything basically about your population. You should cover it. So that's a representative sample. So let's say the total population size is 300 million. Our sample can be maybe 200,000, 300,000. You get out of 300 million. So that's just a very small thing out of that. So that's our sample. So how do we get a representative sample from our population? We do what is called random sampling. So you are not going to be biased. whoever you are picking to ask some questions on depression and nicotine dependence, you have to pick them randomly. So if you pick people randomly, we will not know who is Yoruba, we will not know who is Hausa, we will not know who is Igbo. At the end of the day, you will see that in your sample you will cover all of those guys. But if you are being biased to just go and look at only Lagos alone, or only Abuja alone, or picking only one tribe, you will not have a representative sample because the population consists of 3 tribes and your sample is only having 1 or 2. So your sample has to be representative. Hence, we do what is called random sampling. It's basic in statistics and in data analytics that you have to know. So I will now go into some terms. They are called the measures of center tendency. We know all this from our mathematics, but what we want to know how to do here is how to apply them to solve problems. Okay. So the first one I will talk about is the mean. The mean is also called the average. Okay, and it's the sum of all the values in the sample divided by the number of value in the sample. Okay. Um. So what we are doing is, imagine we have a lot of data now. Let's say we have data on transaction, sales transaction, and there are about 500 entries of the sales transaction. It will not make sense. Let's say you now want to go and give a presentation to your team, and they're like, okay, let's know the sales, let's know our sales, and then you now go to their front, you now start saying, okay, for day one we made this, for day two we made this, and you're going to about, so it will not make sense. What you do basically is you are going to summarize that data. You summarize everything to one number, and those numbers are called location. So you give location to your data, something that you can use to summarize everything. And hence, we use the mean and the median. These are measures of location or measures of center tendency. So the mean is also called the average. So instead of calling each of the transaction, you call the average price or the average sale that was made. You can say on an average we made 500,000. It does not mean that you made 500,000 every day. You might have made 350,000 one day. You might have made 600 one day. You might have made 550. You might have made 500. But to summarize it, you can say on an average we made 500,000. So that is a mean. So a mean is the sum of all the values in your sample divided by the number of values. That's to calculate it, but you will not need to calculate it. The tools will help you to calculate it. Now, remember that we have 2 things we are focusing on. We are focusing on the sample and the population, Abi. So what we are doing is we are going to analyze our sample and we are going to make an inference on our population. So the decision that we are going to make or the findings we get from our sample, we are going to use it on our population. So the mean for the population is noted as this symbol here called mu. This is mu. So this is the mean of the population. Why the mean of the sample? I don't know why it did not show. Let me remove the animation from it. Uh, Okay, so we have the mean for the population and we have the mean for the sample. So what we are going to be getting in our analysis is the mean of the sample because we are working with the sample, right? So the mean of the sample is denoted as X bar. That's what we can see there. X bar. Let me move it to the right place. Okay. Okay. So don't forget that we are working with the sample. Okay, so the mean we get from the sample is noted as X bar, which is the formula summation X over, actually it's N minus 1, not N here, because um, the well, there is a rule of thumb to that formula. It can be either n or n minus 1. I think if your data is less than 10 or 15 or so, you have n minus 1. But if it's greater than that, you have n. But then, whatever mean you are getting in your analysis is for the sample. So this is what we are not going to use to estimate the mean for the population, which is the mu that we can see. That thing that looks like U, that bold U, that is the mean of the population. So the next kind of parameter, or the next kind of location we used for summarizing or for location is the median. So we all know that the median is the middle number. It separates the higher half from the lower half. So it's the middle number. But we have to arrange it in a particular order, maybe from ascending order or descending order. For example, if you have 1 to 11, if you arrange it from 1 to 11, the middle number will be 6. So it's separating 1 to 5 and it's separating 7 to 11, basically. So that's because it's an odd number of data. But if you're having 10, we have to add the two middle number. And if you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the two middle number will be, I think, 5 and 6. So it's separating 1 to 4. No, it's 5 and 6, or 4 and 5. We shall be having two middle number that we have to find the average of those two. So we're having a decimal output. So, but basically, don't worry yourself about any abstract math. Just know that the median is the middle number, and we can use the median for location. So we can use the median to give a summary of our finding. So we can either say we saw, we made an average of, or you can say we made a median of it. These two are used, but the one that is mostly used is the average. Okay. All right. So the variance is another one we should know, and it measures the dispersion around the mean. Okay. So because in the sample, we're going to get our mean from the sample, but then there'll be a variance around the mean. Okay. The variance is the spread, how spread your measurements are around the mean. So what we want is a very low variance, because when we have high variance, it tends to probably make us have inaccurate findings or non-significant findings. But don't worry about this, just know about all these guys. And then we have the standard deviation, which is the square root of the variance. So we're using the standard deviation basically. So this, just like we have the mean for the sample and the population, we also have the standard deviation for the mean, for the sample and the population. So the standard deviation for the population is denoted as S, capital letter S. But what we have here is sigma, which is for the population. Okay, so this is what we'll be looking at in our analysis. We'll be getting estimates, which is the X bar, and S, which is the sample mean and sample standard deviation. So we'll use these guys to make an inference on the population, which is mu and sigma. Okay, so this is just some statistics that we should know. Okay, so another thing that we should know is hypothesis testing. Now, in statistics, what we do is we test hypothesis. Okay, for instance, that nicotine example. Now, maybe our hypothesis is depression causes nicotine dependence, or depression causes smoking. That is an hypothesis. We have to prove it. Okay, what do we do to prove it? We have to gather data for our evidence. So we gather data from the two variables, and we analyze these two guys. So what we did there is an hypothesis. An hypothesis is an educated guess about something in the world, okay, around you. So what we do is we make two types of hypothesis. The first hypothesis is called the null hypothesis, and it means the mean of the groups are equal. What this means is, okay, for example, our null hypothesis can be depression does not influence nicotine dependence. That's an example. So basically, in this kind of this example now, we were interested to know if depression is an influence factor on nicotine dependence. Okay, so our null hypothesis would be depression does not influence nicotine, while our alternative hypothesis, depression influences nicotine. So how do you actually know which hypothesis you should use? It's actually from your analysis. Okay, and there are some values you are going to look at. Okay, so when I say the means of the group are equal, it means there is no significant difference between the two variables. That means for the null hypothesis, whatever we are trying to find is not significant. While for the alternative hypothesis, whatever we are trying to find is significant. Okay, but we have to know what to look at to choose between these two, and that is the p-value. Now, when we do our analysis in this program, and we do some analysis, we'll be looking at some parameters. One is the p-value. The p-value is a probability, basically. It's a probability value. P stands for probability, and it is the probability that determines if our result from the sample is significant. And it measures the probability that an observed difference could have occurred by chance. You know, we are dealing with a sample, right? We want to analyze a sample. So we need to really confirm our findings from the sample. Hence, all this analysis, you have to know your p-value, you have to know your R square. So the p-value will tell us if let's imagine that we plotted a graph of two numerical variables now, and then we got some findings, we got the equation, we got their correlation and all. So we want to know if our findings is significant. Okay, so we use the p-value to let us decide that. And there is a rule of thumb. The threshold for the p-value to know if it is significant is 0.05. Just know all these key things. Don't really disturb yourself about the main stuff, but you can on your own go and make more research. But I'm just giving you the key stuff. So the threshold to know your significance using the p-value is 0.05. So if your p-value, this p-value you will not calculate by yourself, is the software that you're using or the tool, maybe Minitab or Python, that will give us this value. So if we get a p-value of less than 0.05, then whatever we have found from our findings is a significant effect, is a significant result. That means, for instance, that nicotine dependence now, assuming we found a low p-value when we analyze it, that shows that we should follow our alternative hypothesis, which means nicotine, which means depression actually affects smoking or nicotine dependence, basically. So just know that if you have a low p-value of less than 0.05, your findings are significant. And we can now translate it to the population, because we are working with the sample and we need to make an inference on the population. So the p-value will allow us to know if it is significant. So if our p-value is greater than or equal to 0.05, we did not have it's either we don't have a real difference or we don't have enough data to prove it. Again, we are working with a sample. So the size of your sample can actually influence your findings. And actually, generally, the larger your sample size, the larger, the more accurate your findings is. Because if you have large data, you can actually know the right thing. It's just like working with the whole population, or anything we get from the population is the final thing. But it is not possible to cover the whole population. So we work with a sample. So if we now analyze from our sample and we get a p-value that is greater than 0.05, it's either we do not have a real difference or we do not have enough data to prove it. Okay. Now, another thing that we will look at again, aside from the p-value, it is the R squared. Now, the R squared is the percentage of variation in the measurement that is explained by the model. So R squared just actually tells us how relevant our p-value is. So aside from knowing how significant your findings are, you need to know the R square value. And the R square value is it ranges from 0 to 100%. Okay. So in general, if your R square is large, then you have a strong influence. You are dealing with your Y variable and your X variable. So you want to know how, to a very large extent, your influence factor is strong enough. So your R square tells us that. So larger R square of, let's say, 70%, 80% shows us that our X variable actually have a significant and irrelevant effect, while a small R square value, shows that whatever we found is quite weak. Okay. So these are what we'll be using for this program. So basically, okay, the last thing I should now talk about is the data analysis techniques. So we know that we have two types of data, numerical and categorical, right? So if our y variable is numerical and our x variable is numerical, we are going to make a regression analysis. Now we are going to the different types of data analysis techniques we are going to be working with. Okay, so if our y variable is numerical and our x variable is numerical, we will make a regression analysis. But if our y variable is numerical and our x variable is categorical, we are going to make an ANOVA analysis. ANOVA is analysis of variance. We might not actually use this, but I'll not go into in-depth details. What I'll do is we are going to make the analysis and I'll teach us how to interpret it when the time comes, okay? So if our y variable is categorical and our x variable is numerical, we are going to make what we call a logistic regression analysis. And if our y variable is categorical and our x variable is categorical, we make a chi-square test. Now, this is like a guide for us to know the kind of analysis to perform on our data, okay? And I've been able to summarize all what we need to perform data analysis on our data, okay? Okay, so that's all for the summarization. I hope you all understood. But if you didn't understand anything, you can ask me questions, okay? I will explain. Now, down to the project we have signed up for. Okay, we have signed up for the Quantium Data Analytics, and I hope we've gotten the data. So the very first thing you do when you are given data sets, in this case, we are given two data sets, one for the customer's behavior and the other one for the transactions, right? So we will not just dive into analysis, of course not. What we have to do first is to study our data and clean it. That's what we call the data cleaning. I put it on the group, data cleaning or data manipulation. So our data, when it's given to us in the raw form, might come with some incorrect format. For instance, we might have date, and the date might not be in the date format. We might have outliers. We might have inconsistencies. We might have different kind of data quality issues. You know, from quality now, data quality. Before we analyze our data has to be to at least to a level good quality, and that means we have to clean it before working with it. So we have to check for irregularities like outliers, inconsistent. Okay, look at this figure I gave us. We have accuracy, that's correct values. We have to check if the values in the data given are correct. We will use common sense most times for all these things. We'll check if data fields are empty. That's the cells, you know, in the Excel, we have some cells that may be empty. So we'll check that too and we'll report those empty cells. You know, we can, okay, values free from contradiction, that is consistency. Example of consistency is, let's say in a colon, you have the variable gender, and gender is of course male and female. But in the column, you have male male and female female. You have then you now have m and you have f in that same column. You have male female mf male female mf, and you're like, do they want to put male as m or they want to leave male as male? So these are things that you have to correct before you start your analysis. So that's consistency. It must be consistent. It's either we use male, female, all true, or we use M, F, all true in that same colon. So we check for that too. Check for other things like abbreviations. We can check for relevance, check for validity. You know, for instance, if you have age variable, let's say we have age colon, and then when we now filter, we see 25, 20, 30, 40, and then in the last part we now saw maybe 150 or 200. We'll be like, is it possible for someone to have this kind of age, or is this a mistake? So that can be an outlier. So something that maybe we have to remove it or replace it. So that's validity, to validate the kind of variables you have. And then you have uniqueness. Uniqueness most times comes with data or the customer ID. Okay, we are working with transactions, right? And we have customers, right? So in standard shops, right, their customers have customer ID. You know, we have customer ID and we have transaction ID. Transaction ID is the ID of whatever transaction you have made. So that one, might not be unique. But what can be unique is the customer ID, because customer ID is for only one person. Maybe you have 100 customers, that means you have 100 customer IDs, and each of those IDs is for one person each. So if you have, maybe you have customer ID of 5 two times 5 you'll be like, in customer ID you have 25, in not in the transaction data set now, um in your customer behavior data set, because in the transaction data set, of course, the same customer can come multiple times to buy something, so you can have the multiple guy come, but it's the same person. But if you are now checking your other data set that should consist of only your customers without the transactions, then the customer ID. But in this our program, I think it is um loyalty number. That's what they use, LYT something number. So that's the customer ID for our program. Okay, so that particular column has to be unique in the customer behavior data set. Okay, so you can check for uniqueness too and other form of data quality issues. So that's the first thing we are going to do on our program. The first task is to study the data and to report to your manager the findings you get. Okay, so what I will do today for to end it, we'll continue tomorrow and go more on this same tax one, but we can start by opening the data set. So let me open the data set here. But then the data set is quite large, man. It's large. For instance, let me open the transaction data set. You can see that even to load taking time. Imagine if we are now to do some form of analysis or making chart. That's why if I to plot graph, we'll just use we'll use Power BI. But at some point, you might just have to just know a little of Python. I beg. Python is because all this loading now. Excel now, we're using some form of formula to find some things. And we have, okay, look at this guy now. Look at this guy. Let me scroll down. Let me scroll down to the last part. Let's see the total number of kidney we have. Let me just scroll down. Guys, see, we have 264,837 entries. Jesus. In fact, if we do something as basic as count if, in Excel we have count if function, say equal to count if, just count the number of data we have, we are going to sleep there. Although it will go, but it will require patience. If you do it, just go and soak gari or drink mineral and come back and you would have seen your this thing. That's why when you watch that introductive video, the person advised us to use Arrow or Python. And I was thinking, you can use Excel job until I now saw the data set that, yeah, if you actually use Excel throughout, we are going to sleep there. But we can actually manage Excel per se. We can just do some, we can finish the task Excel, but we'll not do some things like that, like the analysis. We can use Minitab to help, and we can use Power BI to make the visualizations, okay? But if need be, if I have to do some things and we have to use Python, it's very easy. All that to do, just go to Python, just load in the libraries in Python or any programming language. There are some libraries you load in. You will call them in, like import. For instance, in Python, they use pandas for analysis. So you say import panda as PD, and then you just say this simple thing like English language that you can relate to, but you see how to use it. Now, look at this data. What's the first thing we are saying? Oh, what we want to do is data cleaning now. That's the first thing, like I told us, data cleaning. So I'm going to expand these guys by double clicking on I'm expanding them, just double click on the margin in between the variables. Okay. Okay, guys, are you with me? Guys, are you with me? Are you with me? Hello, are you with me? Can you hear me?
I can hear you.
Yes, I'm with you.
Okay, now this is our transaction data set from the client. The first row is the date information. But look at the date. We have 43, we have 4399, 43390, 43599. This is basically not a date format. Okay, it's not a date. It doesn't even look like a date. So in Excel, there's where we can go to change format basically. But um okay, then I can see what you are saying, but let me do what I did. Then maybe if it's not this, you can actually omit your mic and tell us what to do. But this is what we can do for date. What we'll do is we'll select this old guy. You press Ctrl Shift and go down, or rather I just click on this guy. But let me check if to get down. Okay, it got down. So to highlight these guys, just click on A. You know it's on A. So click on A. So it will highlight these guys. What you do is look at my cursor. You go to this place where you see general. So you click on general. We have started cleaning our data. So this is a first issue that we will report to the manager that, oh, when I was studying the data, I saw that the date format was wrong. So I corrected that. So you can just note that. So you come here under general, you see short date and long date. But we would love to work with the short date. We don't want to see long date. So let's work with short date. So what will happen now if I click on short date? Now, what has happened? We can now see a date that we can relate to. For the first one, actually the date format is month, day, and year. Month, day, and year. So we have 17th of October 2018. Now we can now understand what you're looking at. So we'll be able to clean the date part. We can do the same thing on Python. You just change format basically. Sharp. It's simple. So the next data we have is the store number. Then we have the loyalty card number, the third column. Now the loyalty card number is what I was explaining that should be unique for each person. But this is a financial or a transaction data set. And like I said, one customer can come multiple times. Okay. So this is the loyalty card number or the maybe the customer ID in some cases, but in this case is the loyalty card number. Then we have the transaction ID, transaction like what the person came to buy. So for instance, if you go to Spa, okay, and then you go and pay in their pay junction, and then they'll give you a receipt. Your receipt to contain your transaction ID, okay, and you yourself can now come again and buy another thing. They'll give you another receipt. That receipt also contain another transaction ID. That's why in this data set, we have as large as 264 entries, because let's say their customers is about 50,000, and those same customers are coming like different times. Of course, we have a large record of transactions. So the next one is product number, prod NBR, product number, and is the number of a particular product. I don't really know well, that's the problem. Then look at this one now. This is product name. Okay, first of all, first of all, who is our client? Our client is a category manager. And what category is she managing? She's managing the category of chips. And in our data, we don't have chips alone. We have chip, we have cheese, we have cream, we have onion, we have chili, we have a lot of them. But the client want us to focus on chips alone. So what we have to do is we have to actually filter this column to only chips. Okay. So how do we filter our data basically? You can select the whole you can select the whole sheet by clicking on the arrow close to A, or you can just basically go to date. When you go to date, press Control Shift, hold it down, then press right. When you press right, you have this, then press down. So you can now select the whole data you are interested in. Then the next place we go to is on our bar here. You see sort and filter. So you click on it, and then you go to filter. So in this place, we can filter and we can also sort. Now, if you click on filter, you will see some drop down beside your variables. So these guys will tell you the data that particular variable contain. Okay, look at this guy now. When I click on the filter for date, it only showed me that okay, we have dates from 2019 and 2018. That means this transaction is a year range from 2018 to 2019, and that particular variable contains different days from 2018 to 2019. So if you go to store number and click on this same arrow, you will you will see the variables in it, and we can from here we can check if they are outliers. Now we can see 1 2 3 4 5 7 9. So we can go down, you can see that the highest number there is 272, and this is store number. Store number is maybe the particular mall is, let's say, ShopRite, and ShopRite can have about 200 malls around Nigeria. So from our data we can see that we have 272 stores for these guys. There's no form of outlier, so I think that guy is good, and there's no blank. Assuming there is blank, that means if any of our cells is empty, we are going to see a blank you know thing there called blank. But since there's no blank here, that means there is no empty data. Then the loyalty card number, that one is quite plain to save. And then we have transaction ID, product number. So now what we want to do, why did we sort? We wanted to sort product name, because product name, if you went through the site, you will see that there's a place where you say you should create additional variables like brand and size. First of all, before we filter, let's study the product name variable. What do we see? For the first time, we see natural, then we see sheep, then we see something like company but it's not spelled correctly, then we saw sea salt, and we saw 175 gram. Now it is it seems that they joined everything together. They joined the brand, they joined, for example, this from this guy, we know that the first name is the brand of the product, because people produce different kind of ships, right? So for this first guy, the natural is the name of the brand, cheap company also is the name of the product, maybe cheap company salt is the name of the product, and then we have 175 grams. That is the size of the product. Okay, so these things cannot be in the same column. We will have to separate them. Okay, but the first thing we need to do is to sort the whole column first to only chips. So we come back to that sort and we click on sort. What's wrong with this laptop? So we click on that arrow and we are to sort out this guy. So if you look at this guy, we can see a lot of them, everything that it contains, and it's up to WW Supreme Cheese. So these are the different brands of the product they have and different sizes. But we are interested for only chips. So you can just come to this your search button here. Come to search button and check for chips, CHIP. You know, some places they press that chip, while some are chips. If you put CHIPS chips, it's going to remove the one that has chip. But we know that due to the person that was putting the data in the first place might have put it wrongly. So let's put chip. Even if you put chip, there's some place where they put CHP, CHP. It's also chips, but they don't spell it well. So these are things we check out for. But now that we have sorted our data to only chips, we will now go and check. Maybe there are some other things that may have chip that's not spelled well. Okay, what you do is after you put your chip, just press OK. When you press OK, what happens? Excel will remove all the other guys that are not, that does not contain chip in them, basically. But if you look at the number to your left, that is the number of the cells 1, 2, 3. You see that we have 1, 2, 4, 8. Now, Excel did not completely remove these guys from this table. It just basically just made them look as if they disappeared, but they are still there. And we can confirm that by the numbering, because the numbering are now jumping 1, 2, 4. That means basically just remove 3, but 3 is there. So I don't know who is good in Excel here that we can maybe turn it to the normal number. But what may I do is I'll go to the long way. I'll just copy out the data and go and paste in a new sheet so that to have the normal number. But before then, we have been able to sort our data to only chips, but there might still be some other guys that are chips, but we're not spelled well. Oh, now that I now went to the sort, you can see that some of the guys are not selected, and that's because they don't contain chips. So we check. Oh, we see that there are some that are selected because they contain chips, and we are only interested in the chips category. Now look at this guy. After Cubs pod, you can see Dorito corn CHP. So with common sense, we know that that is corn chips, but because we sort out with CHIP, that guy was not selected. But we know that it's also a chip product, so we select it and might, correct it. So we go again, we check. You check if anyone has something like chip. Just carefully go. Oh, we can now see uh think there's someone that's let's see. I think I saw look at these guys, Ketsu. You have to be very careful. Look at Ketsu Tortilla. These guys have CHPS. So basically, maybe the person omitted I or just spelled chips as CHPS. But these guys are also chips category. So I think these are the only guys that are remaining for chips. So we have basically successfully selected the chips category. So we press OK. Okay. So before we actually move all these guys to the new data set, we're still going to clean it. So what is the first thing we cleaned? We made sure that the date is in the correct format first. Then we checked the product colon, and we filtered the colon to only chips because we are interested in only chips. And if you look, our variables will actually reduce. But if I go down, you'll still see the same number of column because Excel has not completely removed them. But if we copy out this data to a new sheet, only chips that are selling in that market or in that mall. But then we need to actually separate some. Like for instance, this product name, we have to separate the brand from the size. So we may not need, in fact, the all of this product name variable or this product name colon may not be useful. What we only need is the brand and the size. Okay, so we can create um what's it called, colon called brand. But how do we do this? We will have to separate them. So in Excel, there's what we use called the delimiters. Okay, we use delimiter in order to separate. So what we do is we don't want to make this sheet look scattered. So we would press Ctrl Shift down to copy all the something from up to down. Ctrl Shift down. Then you press Ctrl C to copy. Then when you press Ctrl C to copy, then you will now open a new sheet with Control N. So a new sheet to be opened, or instead of opening a new sheet self, instead of dissolve yourself to press in a new sheet, you can hardly go back to that data. Where is it self? Let's close this new sheet that we made, and let's open. You can see that even Excel is responding slow because of the type of the size of data. So instead of opening a new workbook, we can open a new sheet. If you come down here, see my cursor, this place you see new sheet. So if you click on it, you have a new sheet in the same data. Okay. Now, mind you, do not tamper with your raw data. What do I say? When I am done with this data set now, I am going to save it as save as. So it will save as another document so that the original data I got from the website will remain intact. That means the one that we've not touched at all, that we've not cleared. We need that guy to remain intact because we might need to get some stuff from it too. Because right now we are doing a category by chips. We might need to compare the sales of chip in relation to other kinds of products. Okay, so we need that original data. So don't tamper with it. Now that I am working with the data, I will not save this data with Ctrl S. I will save it as save as, so that it will save as another document. Okay, so I have copied out the product column. What do? I'll just Ctrl V here. So I have copied out this guy. So you can expand it by just double tapping on the margin. So it's even loading safe. Can you see? Ordinary copy and paste already loading. Man, it's still Python will use last. Daniel, are you here? So let's go and see how you can help us with Python. But what we'll do is the initial findings for tax 1, we can finish tax 1 with Excel actually. Okay, we can finish tax 1. So I have copied product name out from Excel because I want to separate brand name from size. Look, I will go to your toolbar. You will see data. Click on data. When you click on data, you will go to text to columns. Just follow my cursor. Text to columns. Click on text to columns. You will see two things: delimiters and fixed width. So leave it at the delimiters and press next. When you press next, now if you see from our column, we see that the first name, which is our brand, we know that's our brand, is separated from the other guys by a space. Even the other guys too are separated by space. So what we want to use delimiter to do is to separate each of the words into different columns because they're separated by space. So we'll uncheck that tab and we'll click on space because they are separated by space. And you see a preview under that. This is how your data will look like. It will be separated this way. So we say, okay, then we say next. Then you can change this guy. Click on general and we can change this guy and leave it at text. Okay, leave it at text, and then you say finish. So do you know what Excel does? Excel helps us to separate each of the words to different cells. So we now have what we're interested in, which is the product brand, not the full thing joined together, because that will not be helpful. So we need them differently. So we have the product brand now. So we can copy out that guy, which is the first guy. Then we go back to the previous guy. Like just click the sheet beside it to go to the previous sheet. Then you can now create a new. You can create a new column called brand. BRAND. So this is the brand, and then we paste what we copied. Okay, the pasting nullified. So we'll go back again. We'll go to sheet 1. Sorry, so we copy this guy that we have separated. We go back to, I think it's sort as in, in, and then we paste it here. Can you see? We have successfully made another variable called brand, and then we have it. Can you see that? Comparing it to prod name that has everything, we don't have everything again. We only have out of the first letter, which is the first word, which is the brand. So we have the brand alone. Okay. Uh, oh, sorry. Let me control Z that because I copied it with the sheet. I want, so you will not start from prod name, you start from natural. Start from natural and then control shift down to copy it. Then you go back to your previous sheet and then you paste it here. Control V. Oh, now we have our brand, natural Smith Kettle. So if you sort, if we sort this guy, or see the brands we are dealing with. So let's sort this guy. Let's sort this guy. Or let's filter this guy. So if we click on the filter of brand, we can now see the brands we are dealing with. And these brands are the brands for only chips. Oh, now look at what we saw now. Aside from the fact that we have all the brands, what do you see? We see blanks. Can you see? So if you filter your column and you see blanks, that shows that there are some cells that are empty. Okay, that shows that the cells are empty, but we will not want to work with empty cells, so just uncheck it. So we are basically removing the cells that are empty. We have to work with all the data. Okay, so let's remove all the cells that are empty. So we uncheck the blank, say okay. So that basically removes all the cells. So another thing that we need to create, let's stop here for tonight. Okay, that we need to create is the size, size. And looking at it, we know that the size is the 175 gram, 300 gram, 33 gram, but we see that this size is joined together what's it called, with other guys, and we want it to be alone. Okay, in Python, all this using of delimiter in Excel, we'll just do separate this and that in Python also, and to sharp, you just give it something, or separate this, separate the numbers. Because right now we want to work with size, okay, and we have it here 175G, 175G. So we want to make only 175G into this size column. So how do we do it? We want to separate the numbers from prod name and put it in size. Okay, and we may want this size self. It may look like a numerical variable because it's size, abi 175G, 175G. But if we think of it clearly, it is fixed to one particular product. Okay, let's say we have a can of cheese and it is 175G. So we're basically referring to a particular categorical thing, which is that thing. So its size in this case is not numerical. Okay, don't go and say go and plot scatter plot. Okay, you have to really understand type of data. The size you are seeing here, they are associated with different kind of products. Okay, because okay, can we say 2 times that size? Because we have the product already sealed. The size is already sealed. Okay, so we can categorize by size, but we cannot say it's a numerical variable. You get. So right now, let us just create the column size. So what we'll do is we'll do the same thing. We don't want to mess up this sheet. So we come to that sheet one, we can basically clear out these guys, or basically use another sheet called sheet two. Okay, so let's copy these guys out. Control shift down, control C, and then we go to sheet two. We can create sheet, just go down, click on that stuff, and you see. So you place this guy. So what we want to do is we want to separate these numbers from these guys. So there's this function we can use. So just follow along. This is the function you should use. The function will help us to separate the number by, what we'll do is we are going to tell Excel from which position we want to separate from. Okay, so how do we do that? Let's follow along. We are going to use this hope I can still remember sha. I've forgotten now. Oh, okay. Who knows how to do it in a very simple way? What is his name? Wait, someone has left messages here. Daniel, are you there? Daniel.
I'm here.
Okay, Daniel. How do you think we can? Although I have it, where is it safe? Uh, okay. You know what? Hold on.
Is it the right or left function?
The right. Yeah. Abi the
You're trying to
data.
take you're trying
Yeah.
to take you're trying to take the last four.
Yeah, we're gonna take the last four guys, okay? Like the numbers, the 125G.
Uh, it should be right or left. I can't remember off the top of my head.
Okay, you know what we should do? What we'll do
It
is
is either right or left. One
Yeah.
X.
let's follow this um formula or this function. Let's see if it's going to work. So equal to min. We open just for your information, Excel is not case sensitive, so you can put it in either capital letter or small letter. Okay, so let's just mean, then find, just follow this function. Okay, then we open this guy, then we put in curly brackets, then we can say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've basically taken all the numbers from 0 to 9, right? Then we close the curly bracket. Okay, then we press a comma. So what is the within text? So we have to basically copy the array, right? So we'll just copy this guy, or instead just paste this guy. Just select on A2. Just select A2 or type A2. Okay, then you press comma, or instead of comma, you press and then you open a string and you press 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's an explanation to this function. So what this function wants to do is it's going to find numbers. Okay, so it's basically going to just go to where the index of where the number starts from and just pick it from there and get it. So let's see if this will work. Oh, okay. What I did now is the index actually. So this 35 mean that the number 1, we are working with 175. So the number 1 is on the 35th index, but we are not interested in the position. What we are interested basically is to extract the number from it. Okay. So I think what we're going to do is use another function. I'm not supposed to use this myself. I'm supposed to use the right function. So this is what I will do. I will do this. I will say, okay, now that I know okay, let's do this guy first. Let's do this guy first. Let's call this guy position. Position, because we'll need this guy, okay? We'll need the position of what we are looking for. So this is the position. Now let's now put another guy and let's call this guy the size. This is the size. So we'll need position for this second function. So press equal to, since our number is towards the right of all the text, so press equal to right, RIGHT, open bracket. We are working with A2, right? So let's press A2, right? Comma, then we'll find the length of A2, LEN, len, and then A2. Simple, just follow this stuff, A2. Then we'll now minus the position. So minus our position is at B2. So just click on B2 or type B2. So we need that guy. Minus B2, then comma. Is it comma now? Not comma, then plus 1. Plus 1. Just follow this formula. So let's see if it's going to help us. Oh wow, we have 175G. Clap for me. Okay, we have successfully separated the what's it called. So how do we apply to all? Just double click on this guy, normal, on the mini box here. Double click, and then we have this guy. We may not have to even double click that guy, but to use this guy, double click. So basically, we have successfully separated the numbers from this guy. So this guy are our sizes. So let's copy this guy out. Oh, can you see that the, oh wow. Can you see that when we copied out the old data into a new sheet, look at our final guy, the final total number of entries, 87,336, and the original was 200,000. That was because we filtered for only chips, so the data was only reduced because they don't sell only chips, but we are analyzing for only chips. Now we have successfully separated the size from that guy. So Control C, and then we go back to our initial sheet, and then we go to size. Okay, we go to size. Wait, what happened here? Okay, we go to size, and then we paste it here. So what I just Control Z, Control Z. Do you know what happened there? Do you know what happened there? In our sheet 2, these guys that we copied are bounded, or they are binded by a formula, which is what you can see in this formula tab here. So if we are going to paste it, we can't just paste it like Ctrl C and Ctrl V. We'll first copy it, and then we are going to use the paste option. So we are going to paste it without the formula. So you right click. When you right click, you see the paste options. You see paste. You see, or instead, let's go to paste this 1, 2, 3 that you see here. Let's click on it. Okay, so what do? We have copied those guys out without the formula, so they are no more binded with the formula. So we just use the paste, because if it doesn't Ctrl C and Ctrl V, the data you are copying, they were made from a calculation from a data, and that data is from that second sheet. So if you are moving them to another place, it's more like you are copying the formula alone to the previous sheet, and you'll be getting value and error, right? So if you are pasting that data from another place, you have to use the paste option, and then you paste it as values 1, 2, 3. So it will just paste without. So if you click on it now, you see that there's no formula. It's just 175G. But if you go to the sheet where you made the calculation, and you click on one of the data, and you click on this guy, look at it, you get the formula. So what we did before is we copied out the formula, not those numbers. But to have the numbers alone, we use the paste option. Now we have gotten to an extent of cleaning our data, and we've done what? We've done data manipulation, because brand and size were not in our data initially. We had to put them in, and that is called data manipulation. We have manipulated our data, and we are still going to manipulate it more, because we need it to be in a format that will help us in our analysis. Okay, in fact, we have to even join the two sheets together. Okay, let's open the second guy, which is the purchase behavior. Okay, let's open the purchase behavior. Let's open the purchase behavior. Now, if you see the purchase behavior consists of only customers' information and their category or their segment. Domo. Hey God, why are you still looking like this now? Just so. Okay, it's there. What am I saying now? Okay. Now, this data set is for the customers. So we have loyalty card number, which should be this for this data set. It should be unique. The first number we have here is 1,000. That means we should only be having 1,000 throughout the column. We should only be having 1,000. And this is their life stage. Their life stage is basically describing them, if either they are young singles or they are couples. So these are the guys we want to know their behavior, and that's what our client is interested in. She wants to know probably if it is the older families that buy chips the more, if it's new families, or which of them spend more on chips, which of them come off to buy chips, how much they buy, all those kind of questions. So, and I will prepare in form of all these 655 that they were not there before. I was gonna put them there. So don't look at these guys, okay? Let's look at the data, and then we have premium customers. So premium customer, we have premium, mainstream, and budget. And from English, I know that premium guys are the guys that come that have more money. Why premium? That means you spend more money on something. They're mainstream, the let's say the middle class, the guys that they spend moderately. And we have budget. If they call you budget, that means everything you buy you put on budget. I no get past 10,000 naira. Everything I want you buy this thing. Hey, you are a budget customer. So those guys, they are the lower part of the class. So we have the premium. So these are the guys. So we will have to actually, join this sheet to the customer's transaction sheet. So we'll join this sheet to this sheet. You see, we have to join the customer's sheet to this sheet, and we're going to be using the function called VLOOKUP.
Sorry, can I ask a question?
Yes.
Okay, so now it means you are already using Excel for this
Yes, I'm
analysis.
using Excel to clean the data. Yes.
Because you said we can't use Excel before, so I was wondering
No,
you are using Excel.
Look, we have 3 tasks, and we have never started working at all. What have we done in a day? We've only filtered. We've only made this way. But when it comes to maybe other plotting graphs, hey, if you go and plot that, oh God, you will sleep there.
Okay, so that's when Python comes in.
For the plotting of graph, we might see if Power BI can help us a little. At least Power BI can do large data sets, so it can help us in terms of visualization. Then for analysis,
fantastic.
maybe want to analyze through variables, we can use Minitab. Maybe we can actually manage without Python, but let's see how it goes. We are working together on this, so I'm not just.
No problem. It's fine.
We all work
No
together.
problem. It's fine.
But then, this is just my own
No
method.
problem. It's fine.
Yeah, so this is just my own method of doing this. Probably you might know some special functions that can do some stuff, far faster than what I did. Like the one I did that is to separate the brand and the size, okay? But then what we just need to do is to prepare our data to start analyzing, okay? So since we have our brand and size, look at the one I did. So after doing this, you will not save this with Control S, so don't save as Control S. You will go to File, you see Save As. Then you go to Save As, and then you call it a name. And you have to differentiate with it. For instance, now I've already saved mine. I put transaction data with brand and size because brand and size did not come with the raw data. I put that myself. So you just say transaction, blah, blah, with just save it how you can, just to know that you have made something, you've made a particular correction on that data, and you've changed the date, and you've calculated, or you've created a new or 2 different variables, brand and size. So you will not, don't even tamper with your raw data at all. Leave it the way it came. Leave it the way it came. You get. So okay. Oh, as we can see, when I pasted that of the brand and size, it seems the numbering came back to normal. So the numbering came back to normal, and we are having, instead of 200 plus, we are having 87,000. So I think we can work with this guy. Since it's less than 100,000, we can work with this guy. So the next thing we should do is to join them together. Look at my own before we call it a day. For instance, I have where is it first? I have transaction and behavior for chips. Let me show you how I joined it together. So this is transaction and behavior for chips. Oh, guys, look at this. Look at this. So what I did here, if you notice, I have date, I have store number, I have loyalty card, I have transaction ID, I have brand, I have size, and then I now have product quality, quantity and total sales. Now, all these guys are from the financial, that are from the transaction data. Now look at the other guys. I now have live stage and I have premium customers. And these guys were gotten from the what? From the behaviors data set. So what I did was I joined these two. And what function did I use? I used VLOOKUP. So if you are joining data, you will not join, you will use you are going to use the transaction sheet to join. You will not go to the customers this, it's on the transaction sheet we use VLOOKUP function. So you come here and you press equal to, I don't know why maybe because I pasted, you see that you cannot see the function up there because I pasted as value. Okay, I just pasted it without this thing, but I use VLOOKUP function here, and probably all of us know how to use VLOOKUP, but I will show us how to do it. Or let me just end it by doing it. Okay, so let me go to, okay, let me go to this is our initial this thing. So let me copy these guys. Let me create a new sheet and copy these guys. No, let me copy from here to product. I will not put product name. Control C, control put new guy and paste. Oh, you see that when I pasted date brought out hash. Don't worry, just highlight it again and go back here and click on date, short date, to go back to normal. So I have product number, so I have to go and copy the rest. So I'm going to be omitting product name. I don't want product name, okay? Oh no, not here, it's here. It's here. Okay, so I don't want this guy in my data, like it's totally useless. But at least I use it to get my brand and my size. So I'll come here and I'll copy out these guys, Control C, and I'll go and paste in my new sheet. So basically, these are the guys I'll be working with. So this is my new transaction sheet now for only the ships, okay? And then I have been able to clean it to this point. So I now want to join, my customers' behavior data to this guy. So what you do is you use a unique number that is present in both data. And in this case, what is present in both data is the loyalty card number, which is, like I said, is unique. Because if you go and check the customer's behavior, transaction behavior, where is it safe? Let me open it again. Transaction behavior. Let me open this one. Okay, this is our transaction behavior data. So you see that they have one thing in common, which is what? Loyalty card number. So we are going to use this guy to match them together. So we're going to use the VLOOKUP, or the other function like match, but I'm more familiar with VLOOKUP. So let's go back to our transaction. Okay, we're using this, all right? So remember that I have made this guy. So I now want to do, so I will come here, I'll press equal to, I'll use VLOOKUP. I'll open the bracket. So what is our lookup value? The lookup value is the unique value you want to use to match the two of them. So we click on what? C2, or you press C2. So that is 1000. So you click on it or you press it, C2, comma, what is the table array? The table array is the array you want to match with this guy. So you will have to carefully, okay, what I did here to make things easier for me was I had to make the behavior be on the same, like on the same sheet, not like the same sheet through. Like I have to open a new sheet from here and call it the sheet 4, and then I will go and copy out this guy so that it will be easier. So you don't make mistake in your VLOOKUP. Just copy out this guy out of his own data, okay, by the behavior, and come back to this guy where we have sheet 4 and paste it here. Let's go and copy it again. It's not copy very well. So copy. So we come to this guy and then we paste. So we have pasted this guy now, right, into the same data set as the other one. So it will make our VLOOKUP function easier, right? So we'll now go to sheet 3, where our, you can rename your sheet 3. You can call it, transaction and what? And behavior. And behavior. You get, so that you can know what you are working with, and behavior. So we can rename, just double click on it. So this is our sheet, what we're going to use. So we'll come here, we'll press equal to VLOOKUP, open bracket. Our VLOOKUP, our lookup value is what? The C2, which is loyalty card number, because it is unique, comma. What's our table array? You carefully go to sheet 4. If you look at your formula bar, you see that you see sheet 4. That's because you are still on that previous sheet, because you are still typing. If you see, the formula guide is still there, because you are still putting in formula. So we are going to copy out these guys. So we need this guy. Just press this and use Ctrl Shift, right, and copy out this guy. So we see that this is part of our VLOOK function. So very carefully, don't go back to the previous one. Finish your formula in this sheet. So just scroll up back. Don't click on any cell when you're using VLOOKUP, it will disturb your formula. Carefully go up back. So we have selected our table array. What's the next thing? Column index. So you are not going to use, you will use your what? You will use your formula bar, which is up here. I've gone up now, comma, and within this guy to finish up the formula. What's our column index? Now we have the column index. The column index number is the number of column. Since we are dealing with this table of array that has loyalty number, life stage, and premium customer, that means index 1 is loyalty number, index 2 is life stage, index 3 is premium customer. But we already have loyalty card in our previous data set. So press comma and press 2. So pressing 2 means we are choosing to match life stage to that sheet. Then we'll now press comma again. So you see approximate match or exact match. Approximate match is basically used for numerical stuff, but this is categorical, young singles, couples. So we want it to be exactly the same way it is, exact match. Then you close your bracket. Be very careful when you're putting this formula. Then press enter. Can you see what happened? It goes back to your previous what's it called? Sheet where you're putting in the formula in the first place. So we're going to call these guys, this guy again. What was the name of these guys? Life stage. So we'll call this guy life stage. So it's all I've done. We are basically fitting life stage into our data within VLOOKUP. So you just apply it by double clicking that guy. When you double click that guy, it loads, and then you have it there. You see now it's taking time because of the number of data.
Michael.
Yeah.
Okay, how about the third data set under this where you did your VLOOKUP form? Are you also adding that one to using VLOOKUP?
Yeah. Say it again.
I mean, from the sheet 4, we have 3 data sets.
Yes.
Yeah. Are we also including the third data set?
You have 2 data sets. you have two data sets. One is the behavior, and the other one is transaction, right? Can you hear me?
No, I'm talking about the sheet 4. Sheet 4. I can hear you. I'm not talking about the data set. I'm talking about the sheet 4. So the third column.
For the sheet 4 now. The sheet
Yes,
4,
yes.
you have to leave it, you have to leave it there. Like you have to save it there because it is working with the formula of VLOOKUP. So if you
No, that is not what I'm saying. That is not what I'm saying, Michael. Can you go back to your sheet 4?
This thing is loading. I don't know why it's taking this time.
Okay.
Well, I can go back. I can go there.
What I'm saying is, the VLOOKUP you did was on to join this light stage to this particular sheet, right?
Yes.
What I'm saying is, are you going to also do that for the other column, the third column? That's what I'm saying. That's what
Sorry. Yes, now we use two. We use two for this guy to bring in live stage.
That's what I'm saying. Okay.
So we are going to copy. Okay, sorry. We are going to copy this formula again and put 3.
Okay. 3 for the second one too. So that means you're adding both the column for live stage and
customer premium
and the third column too. Okay, to this one. Okay, that's what I'm asking.
Yes.
Okay, that's fine.
Yeah, so we'll be having these two data together, so we cannot make more analysis on it.
Okay.
This is
Analysis. Okay.
Yeah, so at least at this point we can safely say that we have what So if you go down, can you imagine this thing is still loading? Well, it's fine. Probably my laptop. This laptop is quite slow. If you use your laptop, it will not be as slow as this actually. But then we all understand the of VLOOKUP. You don't have to write the VLOOKUP function again. Just copy it from this place. But don't tamper with it. To copy from here, paste in the second column beside live stage, and change that 2 to 3. So it's going to bring in. I'm going to do this, but at the end of the day, this is what it should be saying. Okay, this is what you will see. If you join them together, you'll be having live stage, and you'll be having premium customer, And after you've done this, you might decide to free the live stage and premium customer you have added. You can try to free it from the formula by copying out all the other data, and then going to paste as as value, so that when you paste it in a new data set, for instance, now that I click on my young singles, can you see the VLOOKUP? No, that's because I pasted all of this as it is, because I would not want my VLOOKUP to disturb me. So think we are able to do this. I swear we have cleaned our data, we have made size and live stage. I think there's still more we have to do for this tax one. I think like a video breakdown. You go decide to call it a night. So we can go and practice what we have learned today. And you can always put in your own words, touch your own and try and check more things. I have shown you what you need to work on, okay, in terms of data exploration. Sorry, not data exploration now. This is data manipulation and data cleaning. So you are basically preparing your data. So we call it data preparation for analysis. So wow, I think we can call it enough. This is 1:45, guys. 1 hour 45 minutes. So I would maybe I'll store this this video into my own YouTube channel, or send it to us as normal. Anyone that is comfortable, so that we can revise and know what to do. Okay. So now we've started the program. So I started by giving us a brief overview of what data analysis is and the little two concepts. And now we have gone as far as cleaning the data a little, but we need to do more from the tax one. If you read the word from the what's it called, from the site, you have to submit your initial findings to your manager. Okay, but we'll conclude tax one tomorrow on filling, and then we'll submit. When we submit, we can now get their own model answer. But their own model answer is in R. R is a programming language for data analysis, and they solve it in R. So it might not be of use to us, but we know what we are doing, okay? Because they put it there on the side that you can use any approach to this, okay? But they have decided to use R on this. So as it goes,
Sorry,
so
Michael. So what's the essence of Michael?
Yeah.
So what's the essence of giving us the answer? Is it for us to compare our own answer with them?
Yeah, for us to compare.
Can you hear me?
Yeah,
Okay. That's fine.
Yeah.
All right. Thank you.
Okay, then let's end this meeting. Then it's getting too long, so we can revise in our free time. Okay. So like
Okay.
we're meeting Saturday and Sunday, so we have the whole week to practice and look at the stuff. But I'll keep us in tab, sharp. All right then.
Thank you, Michael.
All right, then.
Thank you, Michael.
Daniel, you will teach us Python if it comes to it to get prepare for also.
You keep saying this thing, but I don't still hear you.
This guy. All right.
Later.
Yeah. Later. Good night.